In this lecture, we discuss three problems on linear programming problem or LPP by graphical method. Here the problem is minimization problem. As you see, this is minimization problem. These are the constraints. First we convert constraints, that is inequations, into equations. First one is converted to x1 by 10 plus x2 by 6 is equal to 1, and this is greater than equal to, so 6 into 0 plus 10 into 0, which is equal to 0, 0 greater than 60, which is not true, so the portion or region will be away from origin. So 10 0 0 6 away from origin. And similarly for the next one, that is 4x1 plus 4x2 greater than equal to 32, it becomes x1 by 8 plus x2 by 8 equal to 1. Here also, as the sign is greater than equal to, the region will be away from origin and it will pass through 8008 and away from origin. So 10006 away from origin, 8008 away from origin. Let us have a look. You see, this is 100, this is 06, and this is away from origin. And for the next one, this is 80, this is 08, as well as away from origin. And the remaining two constraints, x1 greater than equal to 0, x2 greater than equal to 0, will give us the entire first quadrant. So the common portion which will be covered by all the inequations is the feasible region, which are shaded here in this part. We call it this feasible region or feasible space. One thing can be noted that this portion is not closed, means this is not bounded. We see here this is not bounded, you see this is open. Our first uh, topic is now to choose one z. Here you see 300x1 plus 400x2. We have to choose one z in such a way that whenever we draw this line, such that it passes through the feasible region. In particular, here we have taken z is equal to 3600. You can take also other value of z, no problem. So considering z is equal to 3600, it becomes x1 by 12 plus x2 by 9 equal to 1. So it passes through 12009. You see, this is the dotted line. This line, dotted line, it passing through the point 120. This is 120 and this is 09. As this is the problem of minimization problem, we move this line towards origin and ultimately it will merge with the point B. The point B can be obtained by solving equation number 2 and equation number 1. So solving 1 and 2, we will get the point B. Solving which we obtain B as 5 3, as you note here 5 3. So x1 is equal to 5, x2 is equal to 3. We will put this value of x1 and x2 here in this objective function. So our final answer is 300 into 5 plus 400 into 3. That means 2700. So the final answer is 5, 3, x1 is equal to 5, x2 is equal to 3, and minimum value of z is 2700. The point is that here the feasible region is unbounded, and although the feasible region is unbounded, still we are getting only one solution, that is the solution is unique, which is here x1 is equal to 5 and x2 is equal to 3. Let us come to the next problem. This is also a minimization problem. First one is objective function, remaining all other are constraints. Let us see one by one. First constant becomes x1 by 3 plus x2 by 18 is equal to 1. It will pass through the point 30, 18, 0, and as this is greater than equal to 0 greater than 18, it is not possible, so the region will be away from origin. For the next one, x1 plus 4x2 greater than equal to 12, that means 12, 0, it will pass through the point 12, 0, 0, 3, as well as the region it will cover away from origin. And the last one, 20x1 plus 10x2 equal to 120, that is it passes through the point 6, 0, 0, 12 after dividing throughout by 120, and this is also the greater than equal to, you see all the three constants are greater than equal to, so the region it will cover again away from origin. So let us see one by one. 30, 18, 0 and away from origin. Here you see this is 30, this is 0, 18 and away from origin. For the next one, this is equation number 2. It will pass through 12, 0, 0, 3 away from origin. 12, 0, 0, 3 away from origin. This is 12, 0, this is 0, 3, and the portion it will cover away from origin. And for the last one, you see it will pass through the point 6, 0, 0, 12 away from origin. 6, 0, 0, 12 away from origin. You see here this is 6, 0 and this is 0, 12 away from origin. So considering all the constraints along with x1 greater than equal to 0, x2 greater than equal to 0, this is the portion which we say feasible region. This is also unbounded, you see no boundary is there, so here also feasible region is unbounded. One more thing is to be noted, the problem is minimization problem, so we have to choose a value of z, so that 4x1 plus 2x2, here we have taken z is equal to 36, so it becomes x1 by 9 plus x2 by 18 is equal to 1, so it will pass through 9, 0, 0, 18, and obviously it will pass through the feasible region. So let us see 9, 0, 0, 18. It has been drawn here, you see by dotted line, this one, you see this is 9, 0, this is 0, 18. As this is a problem of minimization problem, we will move this line towards origin parallel to itself. towards origin. Ultimately, it will coincide with the line BC. Why? You see, 4x1 plus 2x2, this is objective function, and 20x1 plus 10x2, if you divide it by 5, it will become again 4x1 plus 2x2. So this is 4x1 plus 2x2, this is also 4x1 plus 2x2. It means these two lines are parallel. It means whenever we will shift this line towards origin, it will coincide ultimately with this line, that is line number 3. So our, instead of getting only one point, here we are getting a line segment BC which contains an infinite number of points. Any point on this line will give us a solution. It may be B only, it may be C, or in between any point B and C. For sake of simplicity, we are considering here the point B. The point B will be obtained by solving the equations 2 and 3. You see, B is the point of intersection of second line and third line, solving which we were getting x1 is equal to 36 by 7, x2 is equal to 12 by 7. Putting these values of x1 and x2 here, that is 4x1 plus 2x2, you see here 4 into 36 by 7, 2 into 12 by 7. After simplification, we will get 24. So our answer is 36 by 7, x1, x2 is equal to 12 by 7, and the minimum value of z equal to 24. Two things we can note here. The feasible region is unbounded. We have already told you, see, there is no boundary. And instead of getting only one solution, we are getting an infinite number of solutions, because any point on the line BC will give us a solution. So although the feasible region is unbounded, here we are getting not a unique solution but an infinite number of solutions. Let us come to the last point of today. This is a maximization problem. As you see, this is objective function. The remaining inequalities are 3 constraints. Let us draw one by one. First, 2x1 plus x2 less than equal to 1. That means x1 by half plus x2 by 1 equal to 1. It will pass through half 0 and 0 1, and as this is less than equal to symbol, so 0 less than equal to 1 satisfies, so it will cover the region towards origin. So 1 by 2 0, 0 1, and towards origin. You see, this is 1 by 2 0, this is 0 1, and the region it will cover towards origin. And for the second one, you see 3x1 plus 4x2 greater than equal to 6. That means x1 by 2 plus x2 by 3 by 2 equal to 1. That means it will pass through the point 2 0 and 0 3 by 2. And as this is greater than equal to sign, so 0 plus 0 equal to 0 greater than equal to 6, which is not true. So the region it will cover away from origin. So it will pass through 2 0, 0 3 by 2, and away from origin. Here you see, this is 2 0, this is 0 3 by 2, and away from origin. away from origin means this point, this portion. And previously we observed for the first constraint, the region it will cover towards origin. And x1 greater than equal to 0, x2 greater than equal to 0 means entire first quadrant. Now you see, you cannot find a common region which will covered by all the constraints. So here we are getting no feasible solution because there is no common portion between these, between that and the full first quadrant. So as there is no feasible region, we will not get any solution. So the point we must note here, this LPP has no solution. We are giving two home tasks here, problem number 8 and 9. Hope you will be able to solve yourself.